Okay, we can start now. Good morning, everyone. Just before starting, I want to do a little promotion. Tomorrow we have a very interesting guided tour about ancient agriculture and terraces in the Negev. As you can see by the pictures, it's beautiful and it has a lot of ancient wisdom and some creativity for the challenges for the next year. So I urge you to come tomorrow, leading by Itzik and Moti and other friends. So there's still space for tomorrow. Okay, so now for our session, and as you can see, forest management, mainly speakers from KKL, but not just, and I would say a few words. Adaptive forest management encompasses the deliberate planning and execution of management practices that are guided by a specific set of objectives, which are in agreement with ongoing forest research and monitoring activities. In this session, we will explore how insights gained from both short-term and long-term research projects have played a crucial role in promoting dry land afforestation and landscape restoration efforts, particularly focusing on the interactions among humans, visitors, and the natural environment. So, the first speaker, I would like Steve to present Steve Munene, and you can read the subject of his lecture.
Shalom. I'm Steve Munene, and we work in Turkana, and the topic is going to be capacity building for sustainable agriculture, water harvesting, grazing management, and afforestation. Okay, these are the topics that we are going to talk about. And okay, thank you. So we are having a long-term development program that is training the people on the desert agriculture and the Furrows in the desert project. And also we are incorporating watershed management and capacity building to the locals. So Furrows in the Desert is a program that we are partnering with. Nice. Thank you very much. Okay, so we are working with different organizations, Missionary Community of St. Paul. We are working with Arava Institute. We are working with the Red Sea and Arava Science Center and many other organizations with this in this project. Most of you, I know you have been to Turkana or you have not been there. So the Turkana is one of the largest county based in Kenya, and being largest is also the least developed because of the scarce resources, natural resources. And its population is around 1 million people, and we are targeting around 200 people in the area. So this is our working area. Population here. This is our area of operation. So we work with the Turkana people. Most of you, how many know about the Turkana, about Masai? I know most of you know about Masai. So they belong the same group. With Turkana, they are semi-nomadic pastoralists who mainly dwell on the livestock product, the blood, the meat, and some shrubs. So basically, the need for this project is due to major problems that we have been facing, major drought. And if you can see from the it's about every 10 years there had been a major drought, and mortality rate being more than 50%. So many people have been dying out of hunger. So this is the climate condition. This is the data we collected from our R&D center in the Bull mission. And you can see we don't have the distinct season. We don't have the middle summer. We don't have the middle winter, spring. So it's around spread from January to December. So we just distinguish the season depending on the heavy storms, calm days, and we have harsh season which runs from January to March, April, and we have the calm season that runs from May to December. This is the major soil types that we have, mostly. There are 4, and the major characteristics that cuts across is low fertility. So in our project, we try to use the compost manure to get the manure from the livestock and to get the old stock from the post-harvest produce, and then we prepare to improve the soil fertility, improve soil drainage to make it okay for the crop production. So this is the former attempt to develop agriculture that has failed due to lack of know-how, lack of proper structure, lack of the guidance to the farmers, and also the old perception is that people thought to bring the pastoral life to big agriculture was going to be a big problem. But after trying and also consultation with the government officials, I remember Amit, when we were starting the project, he went ahead to meet with the Prime Minister by then, who was former late Raila Odinga, and they said it's not possible to do agriculture in Turkana because of those conditions. But with his brave, we continue to prove a concept. And this is some of the projects that has failed due to lack of ongoing capacity building to the farmers and lack of agriculture input support to the farmers. And in the first picture you can see it was a project that was started by Red Cross in the year 2012, and within 2 years everything was collapsed because they didn't have the follow-up and the knowledge from the field. And the second one is another project, the big project by the county government, which had around 420 plots. So big, they put every structure, all the drip irrigation, the tanks, and they failed also due to lack of knowledge. This is 2 years later, you can see abandoned drip line blocks, and no inactive farms, you can see here, because of those gaps they never put in post into consideration. So this is a successful partnership that we have done with the county. After 2 years of trial, they saw what Furrows is doing, and now in 8 years here, when we were 8 years old, and then they came to us, and then they partnered with us by sending 10 farmers to be trained with us, and also we did the drip irrigation system. This was year 2020, and in the year 2023 they planted. You can see the things are growing, and this is now the current situation. So 5 years down the line, with our guidance, with our inputs, we are active. So this is a working case study that we have done, partnering with the government. So these are our 3 pillars that make our projects work. The first thing is the capacity building, the training. We have a training center where we train the local people for 5 months. They learn by doing, because due to our nature of our participants, who are the farmers, the Turkana community, they are limited to formal education. So in our training, we do learning by doing. 90% is the practicals. They work very hard under the fields. They do practical with our trainers. We guide them each and everything as we explain. For 5 months. Then after there, they graduate, and then we do the drip irrigation system installation. So we have a work team, experts that they do the irrigations back to the farms where they are coming from. And now the third one, being a long-term project, is extension services. So every month we are committed to go around, to visit the farmers, to help them, to guide them, to link them, different organizations, the market strategies, and even train them with the new trends that are there in the market. So these are the installations in the farm during the extension services. So this is our model now, how it works. As I said, the gap was food insecurity. So the first thing is to support food security, reduce agriculture in Turkana, and also for income generation, not only for them, for their own consumption. The farmers also, they have the chance to produce food for their own income generation. So this is now the research center. We have the demonstration farm in Lobul, and we train for 5 months. Like that, they graduate, and then they have 2 assistants whom they train them right from their field, and they work with them together, and then they form a cluster and then an association that help them to link to the county government and another organization and market strategy. So this in picture form, this is now our model farm, this is the demonstration farm where they work and they stay for 5 months. This is during the field work, and also we teach the key, the very important element within our Lobul where we stay. There is schools that are around, and also we have some lessons with the young kids to teach them on the issue of the agriculture production, and also we have the date plantation experiment. So this is what happened during the 5 months. So this is the theoretical lessons where we have to explain some terminology, what is compost, what is land cultivation, protection, and this is now the practical session. So you can see mostly our participants are ladies, because when you empower women, you empower the entire community, right? So this is how we do. This is the nursery, this is the drip irrigation system. Also, it's very important to use a low-fed gravity drip irrigation system. We need 8 mm pipes that easy to increase the pressure, and also easy to do the drip blockage when we face those challenges. So this is the practical lesson on crop production. Apart from the open field, we also do the net house production. You see? So we produce some tomatoes, and yes. So this is the post-harvesting. So this is a key thing also. You see, as I mentioned earlier, these are pastoralists. So they don't include their vegetable as a diet. So during the training, we teach them how to prepare different vegetables like okra, tomatoes, spinach, and also we teach them how it is beneficial, the nutrition value to their bodies. So this is the first thing, that once they graduate, they have to go and teach their local community, and also through teaching this, they also create demand to their farmers, to their local people, because they are their first customers. Those are the targets. So this is more of what we grow. We have the squash, a small store, capsicum, pawpaw, bananas, Bolivar. And in this picture, I want you to see this is a dirt and this is the fence. You can see many animals, livestock around, 1,000 livestock. So this means we need to prevent, to protect by using the fence. All what we do to prevent the damage from the livestock. So after 5 months training, this is what now comes. Before they train, we have to take our graduates, our trainees, to the farmers, to the exposure tour, to explain to them, to ask them how they are solving the challenges they are facing right in their farm, and which local way, how are they adopting to the dynamics. So after that, they come 2 days later. This is the graduation day. You get the certificate. And this during the ceremony. Turkana people, they like dancing, so you need to come there and experience this. Moti knows, yeah? She has been there. So these are our operation areas. After graduation now, they go back to their community. So this is where we have been. And in yellow, this is the map of our plots, our farms. And now we are trying to concentrate here, southern part, to have another team. 2, try to put more farms and also to do the monitoring, because it's a lot of work moving up and down for the field work. Good. So this is what we do now. This is now the farms of the farmers after the graduation in different places. So you can see those are the squash. This is the director who is a Spanish lady who we are working with in Turkana. I'm the one here. So this is the agronomic team that is based in Turkana and their local people. So these are the farms, and also now this is one of the farmer taking his produce to the market. You can see some onions, some vegetable in the sack there, taking them to the market. And as I said about the compost, this is the compost that we make right from the graduate farm. And these are examples what we grow. So apart from that, we have the adaptation of Israeli know-how. We brought some dates from Israel in 2017. They were brought there. We experiment the performance with alkali water. And now this is the findings in those few years. You can see we got some produce in 2022. And now in 2025, we are facing some challenges that are opening to everyone who has the expertise in the date production, because we are facing an irregular flowering of the dates due to climate and the season. We don't have the distinct climate, as I said earlier. So that's why we don't have the issue of the irregular flowering. So we have now brought the watershed management right to the farms that we have in different places to prevent the issue of the soil erosion, to increase the food security through the local food production, and also to act as a windbreakers to the farms that begin. So together with our Moti, this is our teacher there, our trainer, who has been coming there since 2019 with Gil to teach us, our team, how to do this kind of watershed structures, how to identify, and they have been passing knowledge to us, and we thank them for this great experience. So we have managed to do some few structures, as you can see, and the key determinant of what we do, the kind of structure, is the local community needs. First, we talk with the community, we explain to them what they need, and we explain the ideas. So from there, we do the surveying, and we come up with different programs for the liman, sheets, and terraces, depending on the structure and the land topography. So these are the tree nursery. We have now a fully operational tree nursery in the Bull Mission training center, and now we can produce up to 9,000 trees, seedlings. So this building survey, this is a local Turkana, being explained and taught by the experts from Israel, Gil and Moti, and this is during the planting of the tree and seedling distribution. So these are the major trees that we grow. So we have decided to grow the local trees that they work better in Turkana. And majorly, the common uses is for the medicinal use, Another use is for the fodder and also for the windbreaker. So this is a major thing that most of the trees that we grow also to promote the food security in the region. So, as I said about the protection, you see, if we don't put the fence, we will not achieve the faster regeneration. The tree seedlings will be interfered with. So that's why we have to come up with different kind of fencing, and it's being determined by different factors. So these are local tree, perimeter fence, and individual trees fencing. So community engagement is paramount in each and every stage. First, we do the community baraza, they call it village meeting, and we invite the stakeholders, we invite the villagers, and we explain to them what ideas we have. Then the next one, we showcase them what has been done in Israel, and with similar condition, even in Israel, is more worse than in Turkana in terms of the water and climate conditions. So after explaining to them, we go back to the field, and then we do the survey. During the survey, after identifying the place with the local communities, then we do the other works with the machines, with the human labor, and then during the planting demonstration, we demonstrate how we do the planting, protection, how we do the mulching, and here is the actual planting of the trees. So this is the whole entire thing. So after planting, you can see after the rain, what happens. These are the contour lines, the demands. So during the rain, we correct the surface runoff, and this helps also in the recharge of the aquifer and the regeneration of the pasture. So these are two case studies that we have done. One is in Lobul. The first one is in Lobul. And you can see after a few years, this was 2 years later, we could see the regeneration of the pasture. The trees were coming very well. And this one is in one of the largest clusters that we have in Opotia. So these are the contour lines that we did. Majorly we did for prevention of soil erosion for these farms. These are the farms. So we were trying to prevent these farms from being eroded. The same case with these terraces, the stone terraces in Opotia. So towards sustainability, according about the agroforestry pasture, we had to introduce the beehive. We did the training for the fodder, and now we are waiting for the bees to be we need to be colonized. So 5 years of impact of afforestation. So in 2019, we moved to the same site. You can mark this one, this is the mission center. So in 2020, this is what happened. 2023, 2025, and this is the impact. So you can see the whole cycle in 5 years. Now we have introduced, you can see some goats there. So we are already grazing in those sites. So another impact, we have observed the improved soil stability, the moringa also, as one of the major trees that we grow, the nutrition value of the place has been improved. And apart from that, these are another NGO that has come to the Lobul mission to check, to benchmark, to see what we are doing. And this is the tree nursery also. They came to be explained and enlightened about what we do and our sectors. So this is the same explanation. The impact for the compost has increased yield, nutrition improved, and farmers now they can produce year round. So we acknowledge all the support from our donors, KKL, Ramot Institute, GEF, and these are our partners that will part this journey. So thank you very much.
Thank you. So, Stephen. So, my name is Imbar. I found your lecture incredible and stimulating and thought-provoking. Personally, I was in Turkana on a gut truck going from Ariel to Lodwar many years ago. That was incredible. And my question to you is, how is the communication conserved with your mentors? Because from what I remember, it was an incredibly long journey through very open spaces. And for example, if you want to ask a question or to show a problem, how do you do this? And I imagine it's probably hard to have internet. So in terms of health and agriculture, as you said, it's important to continue this kind of mentoring. And I would really love to know how you do it.
Okay, thank you very much for your question. Yeah, it's true we had difficulties, but now it has reduced, especially with the network connection. So now the internet access has really improved, especially from where we work. We have now, for the last 3-4 years, we're in a better position. But initially, we were also using the satellite to promote the connectivity with our partners in different regions.
Hi, my name is Ona, and I'm from here, from this institute. Incredible compliments. Thank you. First, I wanted to ask, how did you select the crops? I wanted to ask why you don't put emphasis on firewood and pasture, but then continuing with your lecture, I understand it very well. So I would like to ask now about the cultural aspect of the turning, shifting from being nomad to agriculture. Can you talk a little bit or a few words?
Okay, maybe I can go back to this slide to answer your question. Yes. So the constant here, you can see every 10 years, for a period of around 50 years, there was a big drought. So animal, people were dying. And they saw there was no sustainability from what they were doing, their culture way. So now, due to that, there was a need to have a sustainable livelihood. And we have our long-term partners with missionary community who have been there for the past 4 decades. So they are there to stay. So through that gap, now, we came back to the community and explained to them why they need a complementary livelihood. We are not doing away from their traditional way. We are complementing to make it more sustainable. And they have accepted, and you can see what we have done with the farmers, the pioneers farmers. And now that's what we are saying. We need a long term because we believe 2 years, 3 years is not enough. We have to work with them. Because this project is about the mindset and changing of the culture. So we need more time and being patient. Of course, there are some cases where farmers or some local people, they don't really take it seriously. But with the time, the ones they take serious, our pioneers, now they become a good ambassadors to the other community. Thank you.
It's fascinating, really. Bravo, your salute for all the projects. In the origin, in the kibbutz, the resources and then the profits were divided equally to people by the size of the family. How does it work here? There is private ownership of fields or trees or sections. How does it work in your place? Yes.
Yeah, it's different. In Turkana, the people, they are individual. We live in different villages individually. So the ownership of the project is owned by the community on individual levels. For those who come for the training, 5-month training, they go, they start their plot, farming business, and now they serve the community through production and selling to the community. So the project is owned by the community but individually. So they get the profit through selling the farm produce to other neighborhoods.
Thank you, Steve. I think it's a beautiful example of transfer of knowledge, of researches and practical knowledge, that some of it was developed here in Israel, in southern region of KKL, and other places. And I think also it's a wonderful opportunity to see how sustainability works. That means it's nature, resources, and also the human and cultural aspects joined together. Thank you. Our next lecture from Dr. Anat Tsafrir, Findings and Applications of Ecological Surveys Prior to Thinning and Renewal of KKL-JNF Forest in the Southern Region.
Okay. Hello, my name is Anat Tsafrir, and I'm an ecologist in KKL-JNF. And I will present to you the ecological survey prior to thinning and renewal of the forest in the southern regions. So, forested area in Israel have unique habitats and biodiversity. Part of the ecological corridors of Israel and are under statutory protection, which means they are important ecologically. In 2014, there was this paper called the Forest Management Policy, and in this paper, one of the goals was supporting Israel's unique biological diversity. And one of the management general principles were diversity, complexity, and patchiness, preserving and encouraging a variety of landscapes, diversity types, habitat, vegetation types, species, and genotypes. So, how do you do all that? How do implementation of the biodiversity and conservation? So, first is the establishment of scientific knowledge, is goal-oriented management, which is a long-term management, and also ongoing forest management, meaning, which is especially when we're going to talking about thinning and forest renewal. Those works in the forests are very crucial for the forest. However, some of this work can be hurt for the biodiversity for plants and other species in the forest. So how do we combine all that? In order to do that, we are doing a survey before the thinning and the renewal of the forest. This project was started in 2020 with KKL and the Deshe Institute, that we established the framework of those ecological survey before renewal and thinning. We established the survey protocols. How do we survey? What do we survey? And basically the whole project. And we also stated what are the species, or what is the list that we survey. in this project, and also set us a very good GIS data for all the findings. And in the end of every survey, there are also a specific instruction for every work in every forest. So, what are we looking for in those surveys? It's not finding all the species or list of what is in the forest. We are looking for specific groups such as protected plant species, rare plant species, endangered plant species, magnificent trees, nesting colonies, dens and bores, and also unique habitats. In this lecture, I'm going to concentrate on the findings of the observation findings of rare and plant species and endangered plant species. And now we'll talk about the southern region. The southern region in KKL it's larger, it's gone to a lot, but most of the forested area is constructed in this site between, let's say, Road and South Tiberias. In this map, the right map, you can see the ecological units that we have in the southern region, which are mostly sanding and calcareous sandstone, which is Kurkar, less alluvial valleys, heavy soils, and desert steppe. All those units are considered less represented in protected areas in Israel. That this is why they are important in terms of biodiversity and protection. And in the left map, you can see all the findings that we found in this ecological survey from 2020 to 2025. And some figures. Altogether, there was 107,000 dunam surveyed, and 1938 species observation. And you can see in the graph this observation in species numbers, observation in blue, species numbers in orange, and in each and every year you see that in the beginning, the first 3 years were pilot, and then we continue this project, and you can see that from year to year we see more and more observations in new species. And altogether we found 112 species, 48 red species, 36 endemic species, and 34 protected species. Now, if we look about species abundance, you can see we can find a lot of rare species. And in the conservation status, you can see that we found, a lot of species in endangered and critically endangered species, which is these two groups. So what do we found? Our findings are in three categories. It's hotspot forest. This is forest that we find a set of species that is very unique. Range expanding species that we didn't, that they're expand their range that we didn't find them before in those areas, and some new discoveries. In this map, I colored the forests that are found to be very unique in ecological terms, biodiversity, very diverse. So the first one is Kiryat Gat. Kiryat Gat forest is very close to Kiryat Gat, to the city Kiryat Gat, and it contains heavy soils. And even though it's very, very close to the city, it still contained a lot of unique species. Now, the name of the species, which are italic, this is endemic species, and the species color in red, there are red species according to the Red Book of Avishmeda. So what did we find there? We found there Biloveria verbardi and Allium stuoberti, and Slavia igi, זמזומדבר בום שהוא הגלגל ומרבת egg. Also on Semi-Arid gigantica, they are all species that are belong to heavy soils, which is another. It's important. It's a habitat which is very much in extinction because it's mostly go to agriculture. And the Yatir forest. Yatir forest, you can see in this map up here. There were several survey between those years, 22, 2025, and we found them some unique species. Some of this is Pholomis herba venti, Shalavit הגלגל. We actually found a big population of these species in a valley, kind of like this one, with heavy soil. And also we found Salvia saerica and Santonera ashkelonica, which are unique for heavy soils. And I want to emphasize this species, Furella negavicis, which is mostly known from the desert, actually, from from the desert. And berry forest, also known with a lot of unique species for stands and with big population of Valeriana femela. And the psor forest, which is an interface between kulkar, sand, and less. And we also found them unique species such as Piriam species nova. It's a new species. It's still not completely listed. And range expanding species. Now, Trifolium Palestineo and Astanis Palestina found a large population in Kisufim and Ruchama forest, but also in other forests in the western Negev, in the Loess. Like I said, Furella negavicis also is the northernmost population found in Yatir forest. And Valerina fumila in Nachal Apsar, it's the biggest of these very endangered species found in the southmost population. Now, new discoveries. We found Madigiko Aina Gruiter Aspesetchen in Ramot forest. This is a new species to Israel. And Neotostema Apollon, we found that in berry forest. And in Psor forest, big population, also new species that was found. And Barion Nova Achiluf, probably will be Achiluf Negev, in a Psor forest. And so what do we do with all this information? After every survey, we have instruction for the specific forest regarding the preferred working season. Marking site before walking. This is marking site before walking. Actually, this work was in the tier. Sometimes to exclude area with dense population, like in this map here. I know it's not very clear, but there's a lot of observation in this area, and eventually we decided not to work here. Instruction for log draggings. And all this information is a very good base for long-term monitoring of this unique population in terms of how they are doing, how vital they are, and what is the best management to work with those populations in the forested area. So altogether, we found out there is a lack of information of species diversity in KKL-JNF forests. This project significantly improved knowledge of rare and threatened species in the forest. Maybe it didn't serve before, maybe because of bad reputation of the forest, but we see here that even in forests with pines and eucalyptus, we found a very unique population of rare and endangered species. So the forest serves as a refuge for rare and threatened species, and this from This form a vital basis for future research, monitoring, conservation, management in forests with endangered plants, which this project is actually ongoing. And that's it. I want to thank the people from the Deshe Institute and the ecological department in the forestry division. Thank you. Those findings that I just show you, if you ask someone from who's more like in the botanic side of the picture, this is very yes, we were very surprised to see some of those findings in the south, some places that we didn't know, we didn't think about that they would be here, and we found big population, new species, and unique forest.
Question is, thank you very much for the interesting talk. Did you find this diversity and these rare plants in areas that had a large density of trees, or rather in areas that form more than the original natural habitat? It was there before the forest.
Both. Both. We found a big population in places that I wouldn't thought of finding them. Also with dense populations, a dense cover or more open. Look, this is in the south, so very dense cover. It's not exactly the forest in the south, but yes, there are places with eucalyptus leaf, and still we found those populations.
And I must say that, for all of us, it's quite new. I mean, to focus and to find those plants and to take them in consideration while we plan our works, and to see how we manage, and in some areas like hotspots, even to create management to support them. Okay. The next presentation by Dr. Naomi Houminer, Rehabilitation of Hebron Stream Tributary near Meitar and Hura.
Hello, so my name is Naomi, and I will talk about the rehabilitation of the tributary. Is a new word for me, Yuval, between Meitar and Hura. So, as you probably, most of you know, that Israel is on a very steep rain gradient from about 1,000 millimeters in the north, all the way to almost zero in Eilat in the south. You have a meeting point between different kinds of vegetation from Mediterranean, Mediterranean, and desert-like vegetation. In Meitar and Hura, we will concentrate in this area, in the is about 200 millimeters of rain annually. Of course, the last 2-3 years we had a big drought, and last year it was about 120, 130 millimeters of rain. If we look closely here, you have Meitar in the north, which is mainly a Jewish city settlement, and Hura is mainly a Bedouin settlement. This is the Hebron River. It starts in the north in Hebron and flows all the way to Beersheba River. And the tributary we are discussing is here. It's next to Meitar forest, which is a human planted forest, mainly conifer and broadleaves. And there is a ecological corridor according to the documents. It's also a part of the Hara Negev and Arava area. And here, as you can see, this is Hura. You see here the road, the venting road, it's the same one here in the picture. And this is the beginning of the tributary. As you can see, all the white dots are waste, mainly concrete and building waste blocks scattered all around. Also, on the left side, you can see an agricultural cultivation of the land, which is illegally cultivated mainly by barley and wheat. As you can see, it's a very disturbed area with a lot of environmental degradation factors, such as waste, ruderal and invasive plants, people running and driving all around with no. It doesn't look like an ecological functioning habitat or system. Also, this area, as Anat said, is mainly loess soil. And loess soil has some important properties. It's made of very fine grains, and also when it gets wet from rain, the soil expands, it seals off, and the water does not penetrate into the soil. This is why we get a lot of runoffs or quick floods when under loess soil. Also, after it gets wet, when it dries, it shrinks and has cracks, so it's very prone for erosion, both by wind and from water. Here we have some examples for erosion and gully heads. On the left side, you can see a very big gully head, and each year it will proceed upstream and will take the soil away from the from the system. And on the right, we have another loess soil gully head. As you can see, the farmer who is farming the land next to it pours some concrete in the gully head, thinking that it will stop the erosion, but he doesn't know that in the next flood, the concrete will go downstream together with the soil and the water. Okay. Another example for a loess plain, you can see the farming where they farm into the stream itself, into the river itself, the riverbed, and also you can see a grazing of a camel, but also there is a grazing of sheep and goats. And all this exploitation and not managing the soil properly causes high degradation of the soil and high degradation of the habitat. Another example for a flood, flash flood nearby, also on loess soil. Replay. As you can see, the flood, it has water and waste. It takes the waste with it. All this area is like the backyard dumping zone of waste. You can see the brown water, which means that the soil is being eroded, and it's not something we want to see. Okay, of course, it has also, it hurts infrastructure and destroys infrastructures. So what can be done? So on the left side, let's say this is a riverbed or a bank. And if it rains, the water, just leave the system like that. If we alter the bed of the river and change the topography, whether with furrows or mini catchments or with small dams, we can plant trees on those small furrows, and when the rain comes, it will not wash away from the system but will linger in, and you get better infiltration, and better wetting zone, and the trees that are being planted, as you can see on the right side, will enjoy this the water. Instead of seeing, let's say, 100 millimeters of rain that will pour the same year, you can see maybe double or 4 times more. So they will think that they will get 400 millimeters of rain and not 100 or 200. So we cannot plant forest or trees wherever we want to. We are still in a state of, and we have laws. So under the building law in Israel, there should be planning or statutory planning for this area, and it should be designated as a forest. So those areas that are designated as forest and have specified planning, we can ask to plant the forest. But before we going and rushing things and planting a forest, we need an ecological survey, like Anat said. And in the ecological survey, here we have the one that regarding Meitar and Hura. Hura is here, Meitar is over there. And here is, this is the Hebron River, and here is where the Tributary is. And it says that this area is highly cultivated. And the findings is that, as we saw in the picture, that a lot of waste throwing around, and also a lot of ruderal and invasive plants, which height that it's not a good ecological and functional river. So after we have this survey, we submit a request for planting the forest to a monitoring committee. The monitoring committee is held by the Ministry of Environment Protection. And we say what are the key findings of the area. As we said, that it's highly disturbed area. We also say what are the planning, what we want to achieve and what we want to do. So we want to do soil conservation and rehabilitation of the stream. We plan on removing the cultivation from the stream banks. We also plan on treating all the waste around it, eradicating invasive species, and planting new trees and open it with years that it will grow as a place that the people can come and enjoy and have picnics around it. Okay. Also, we in the program we say what kind of trees we are planning to plant. As you can see, native broadleaf desert trees. What is the density? And we also give a map, a general map of the area. In the map, we say where is the main points of waste, where we want to do little dams and plant lemons, and where we plan on having furrows and mini catchments. As you can see, the monitoring committee was held in 2020, and it was passed by the majority. It was accepted by the majority in a majority vote. And it went into a working plan, and 2 years later, we started working. We cleaned up the area. We built small dams. And after that, we had a detailed planting map. The main species we used are tamarix, Vachelia, which is acacia, but now it's called Vachelia, Vachelia gerardi, and Vachelia tortilis, and also Sisyphus. And in Tu B'Shvat, we had a ceremony together with people, the population from Hura and from Eitan, and together we planted all the tributary. So we can see from maps from Gov map, and on the right we have the before with all the waste in the white dots, and after you can see, like in your presentation, with mini catchments over here, all the little mini catchments and lemons. So you can see it's much cleaner and greener. Here are the trees 2 years later. It takes it's only 120, 150 millimeters of rain. The growing of the trees are much slower than what you saw. So it takes time. We need patience. But this is the good side. But this is a picture from yesterday. I asked the forester to go there and see how it's doing, and send me this picture. Someone again threw rubbish in the canal next to the tributary. So it's a work. It's not like we planted it and we can go home. We have to maintain it. So, in summary, the key things I want to take home message I want you to take. So, first of all, we don't do an ecological restoration. It's not an ecological restoration. It's a functional habitat rehabilitation. Because it's not like we're taking the river back to what it was, let's say, 1,000 years ago. It's not that. We want it to be a functional ecological stream, clean, and the native species to come and return into and do the thing and come back and rehabilitate. But we are not doing an ecological rehabilitation. We treated the invasive species. We clean up the waste, and we are cleaning again and again when it's being thrown. There should be more supervision about it. But it's not our job at the police. We also, this area is now a part of the ecological corridors. We also strengthen the community forest relations, both between Hura and Meitar and between Hura and Meitar in the forest. And we also show a stewardship of the land. And by showing a stewardship of the land, we hope that the people will stop throwing waste and will treat it properly, and it will become another part of the Meitar forest. That's all. Thank you.
Thank you. Great. I live nearby. You declared something at the end of your lecture about rehabilitation and so, and I would like to ask you on both. I understand the treatment of the runoff. Is there going to be any run-on in the Wadi itself after taking care of the runoff? And how much? And I don't really understand why not to have a reference point. You kind of declared that you don't rehabilitate or restore, or maybe rehabilitate but don't restore. Why not to have a reference point to the Wadi in the landscape before? It could be maybe agricultural Wadi, maybe before that, but to have some reference point and to say, okay, we don't restore to this point, we don't restore to this point. We know what are the advantages of each form, landscape form, and we have a very clear goal in our rehabilitation.
First of all, I don't believe this area can be ecologically rehabilitated, or let's say not functional but ecological, because upstream we have Hura. So Hura now, all the runoff from the city is going down the stream. So I must have a more, let's say, practical, but more robust system to handle the runoff, because now it's not like the upstream can absorb the water, but the downstream, so we get much more flood or much more influx into the system than before that. Okay. The other thing, we have a tributary, another tributary northern to that, which nobody takes care of it, and it's a dumping zone of waste. So, as I see it, is either we show stewardship of the land by managing with lemons and mini catchments, and people can see we need something that's like a flag, which puts someone is taking care of the soil. Otherwise, people think we just cleaned up, we can throw again. So, in a way, a tree marks a territory. Very strangely, but this is the especially in areas that we are not 24/7 there. Okay. About how after altering the land and having a micro-catchment and inlands, we still have flash floods. I don't know how much of the water stays in upstream, how much it goes down, but as you saw, last week or 10 days ago, the floods in Beersheba River and Hebron River were enormous. It did not affect that. So I don't know how much it stays in, but enough to support trees.
Can you elaborate more on the point of surfing in community forest relations? I mean, at the end, this is supposed to serve the people of Hura, I guess, and it's very important to take care of it. So, how do you מתמודדים עם זה?
So before we entered the forest, it was in collaboration with Hura. We asked them to monitor the waste throwing around. Also in Tributary, the population came and helped us plant the trees. I can ask what if there is continuing on יש עוד פעילות? So after the plantation we had 2 years ago or so, and also they said that grazing is going into the area with the local.
Okay, our next speaker is Mr. Eitan, Elgar. His presentation is Ramot Forest Renewal, Managing a Semi-Arid Forest Amidst Climate Change.
Hi, so my name is Eitan, and I work as a regional forest management forester in Hara Negev in Arava region. It spreads all the way from south, from Anat to the north, to forest. And it's a very diverse region. But today I'm going to talk about one aspect that we got there, and about one forest, that's a remote forest, and about its renewal and managing. So, Ramot Forest is located just next to Beersheba. Beersheba is in the North Negev. It's called the capital of the Negev. We got about 220,000 people in it. Ramot neighborhood is the biggest, the largest neighborhood in Beersheba. And just adjacent to the neighborhood is Ramot Forest, to the northeast of Beersheba. So, it's located really nearby the neighborhood. You can see how close it is, and especially the coniferous forest. You can see that initially it was planted in the main species were Aleppo pine, Butte pine, and Mediterranean cypress. A bit about the forest history. And I'm talking about this area again. So the forest was originally planted as a temporary green belt. It was not supposed to stay as forest for many years. But in recent years, residential development in the Ramot neighborhood has extended up to the forest, and the neighborhood it was planned to expand up to close to route number 40, which is this here, in the areas that now the forest exists. And as a result of the construction, again, the community was created that is physically close to the forest. Okay, so I'm talking about those areas of the neighborhood that are really nearby the forest just here. Okay, so again, the community got really close to the forest, and a few years ago, a couple of years ago, we declared the forest as a community forest. And the purpose is to enhance the community engagement in the forest, and we do it through a few things. First of all, we hold a round table between the members of the community, members of the municipality, and us foresters. In this round table, we talk about the forest planning, activities in forest, and so on. We got a part-time community coordinator that helps us with those activities. We held a forest trustee course in which members of the community learned about different aspects of the forest and help us when we see problems in the forest and so on. And we encourage kindergarten visits, school visits, and other informal events that happens whether we encourage them or not. You can see a few of our activities over there. We manage the forest for various ecosystem services. So for recreation, and you got beehives in the forest, sheep grazing. It serves as an ecological habitat. You've got archaeological sites and heritage sites in it, and also for the carbon infestation. So a little bit about planning. So the former development plan of the city, actually, this plan, it was supposed to be a residential area. So all of it was supposed to be buildings, schools, whatnot. Now, after during the last few years, the municipality understood that it's maybe more valuable for them as an open space, as a forest, than a residential. So they actually designated as forest, as open areas in the new master plan. And today we are planning a detailed statutory plan in which the forest will basically stay forest, residential. So in that sense, you can say that the presence of trees played a key role in preserving the area as an open space, rather than. But again, just like mentioned before, Beersheba is in a semi-arid area, which is very dry. In the last few years, even more than usual. So our average rainfall is about 200, a little bit more than 200 millimeters. In the last 4 years, you see we collect the water and we measure it. So we got only to the average of 124 millimeters a year. And that's, when you got this effect year after year, the forest, especially the coniferous forest, really suffers. And I must say that Beersheba is located in the border between, it's a semi-arid area, okay, border between semi-arid and desert. So usually you will have desert vegetation over there, and prairie vegetation, not coniferous. So again, that's when we talk about there's so few rains, we actually got the drought, and that's what we get when we get coniferous forest and drought. So the drought caused widespread tree mortality. And again, the coniferous forest is comprised of Aleppo pine, Butia pine, Mediterranean cypress, and some Canary Island pine. And it's located outside the coniferous species phytogeography distribution area. So for us as foresters, that's a big problem. And again, when we see that the population, the people in the Hebron use mostly the coniferous forest, that's an even bigger problem or challenge, you might say. So in order to maybe renew the forest or to think about what we can do, we tried to do some kind of mortality analysis, and we noticed that there are different tree mortality patterns in the forest. And usually the slope aspect was crucial for this. So in the north and west facing slopes, you can still find some really nice groves of trees. Conifers like this one, and then the south and east facing the slopes, it looks more like this slope. Okay, it used to look much better a few years ago. Now we got mostly dead trees, some green trees, a lot of open space. Also, we noticed a big difference in the mortality between the different species. So the Butia pine suffered more or faster before the Aleppo pine did. Also the Canary pine died a little bit before the Aleppo pine. And then the desert species mortality rate was much lower. So most of them didn't die. I must say that in this forest, usually the desert species are planted down in the valleys, just like here. So before renewal, before doing the renewal, we had some surveys. Anat elaborated a lot about how we do it, so we surveyed for the preservation of ecological values, and of course every work that we do with ecologists and archaeologists, and the values that were present in the place. And we took a few forest renewal practices in order to have a good, healthy, and attractive forest. So the first of all is functional restoration by runoff manipulation. All of the photos here were taken just a week ago and 2 weeks ago. Naomi talked about the runoff manipulation, so I won't talk about it, but it was all just the last few weeks, and you can see the water that are in the Furrows, in the lemons, etc. And then another measure that we took, another practice, was planting more local species that are adapted to the arid environment. So twisted acacia, Negev acacia, desert broom or rattan, and the Aleppo pine that we use. So it's seedlings that were grown from seeds collected from superior trees in the region's forest. So, for example, here we can see the collection. We did it like 3 years ago. We started with collecting seeds from good for trees that manage in really harsh environments. This example, for example, is from East Yatir forest. So that's the harshest part in the forest. We also took in account again the slope aspect and mapped so slope again. You can see the northwest and east south, southeast. Slope percentage and soil versus rock. And of course, that when we talk about shears, furrows and lemons, etc., are good for soil areas with a lot of soil. We also got rocky areas over there, and then we didn't use those methods. Having all of those into consideration, we came up with this planting map. So you can see the different slope aspects. The blue is south and east-facing slope, and then we'll have Negev acacia, twisted acacia, Ratem, and the north and west we'll have Aleppo pine, Mediterranean cypress. Remember before it was all basically Brute pine, Aleppo pine, and Mediterranean cypress. Places with a lot of nature values, etc. We didn't do much about planting wise. In this area, we already planted the last year, about 10 months ago. That's why but it would have been blue, and you can see here the Negev acacia in a slope that was formerly occupied by pines. Also, the density is much lower in those slopes. So to conclude, in order to protect remote forest from building, etc., we must have the community engagement. We take different measures to ensure this community engagement. First and foremost, as foresters, we must have healthy and thriving forest and attractive forest. Forest that people will come to. And to achieve this, we should adapt to the harsh climate conditions and use different forest renewal practices to consider the microhabitat features, do functional restoration by runoff manipulation, and plant more local species that are adapted to the arid environment. That's it. Thank you.
Okay, thank you very much for the great presentation. My question is, how do you manage the fires in the forest? Which mitigation do you put into place? The next thing is, how do you prevent mortality? Like now we are doing the same project in Turkana, and I found it an interesting topic about the mortality. How can we prevent it? Thank you. Yes, the tree mortality.
Thank you for the question. So first it was about fires, right? So here we don't have a great problem of fires because we don't have such a dense forest, but we do have a fire hazard maps, and we actually got people. As foresters, we work as we got how do you say kabait? We got fire trucks, and in the summertime, when it's more prone to have fires, we are always ready. We got people that are on a short notice can come and put off the fire. And we had some small fires here as well. When forest was denser, it was a bigger problem. So about tree mortality, in a coniferous forest, usually you just plant the trees a bit denser, and then some of them die. It's okay, later on you thin them anyways. In the broadleaf trees, we take really good care of them in the first 3-4 years. We irrigate them. If there's a need, we plant new trees because some will surely die. But after 3-4 years, usually it will be okay. And again, sometimes planting a little bit closer or denser than what you want to be in the end is good as well. Yeah. We control grazing. So here in the forest we got one herd, basically. They don't even get to all of the forest. It's a bit too big because they stay on the other side of it. But yeah, we control it, and we control also the amount of. It's mostly sheep. They're allowed to have few goats. Because goats are much more. They eat trees really easily. Shift will be more about the green grass. Yeah, sure, we control it. We know who is there, when is there. Summertime, winter time, he won't be there. Spring will get in. When there is not enough food for the ships, will be out. So it's seasonal. It's not throughout the year. Yeah.
I would add that I don't know if you know, but Ramot forest is a nice example of step-by-step restoration. That means initially the trees were planted when it wasn't supposed to be a forest at all. So first step is just preserving the land from degradation. Then, by the years, it became forest, statutory forest, and then we have our challenges of dryness and all this, but it's quite interesting. In terms of the Israeli reality, it's very important to learn from this example. Okay, so the last speaker, Dr. Ariel Meroz from the Dead Sea and Arava Center. Remote sensing, assessment of Conifer dieback in southern Israel during the 24-25 drought.
Thank you. Thank you very much, and thank you for staying with me till this hour. This work was done by myself and Naomi, both of us of the Dead Sea and Arava Science Center. And Eitan gave me a little bit of an introduction of the effect of the drought to the forests, and we have a kind of a large overlook of what goes around in all of the forests in the central and southern Israel. Okay, so according to the Israel Meteorological Survey, the drought of 24-25 was among the three most severe droughts in Israel since the measurement started, since the 1950s. The accumulated rainfall over Israel was between 40 to 65% of rainfall, and the rain year is characterized by extreme events which are accompanied by long dry spells. It means that we have, as last November, as the event of last week, that we had a very dry November, then an extreme event, and again continuous drying. And this goes on, and now we are not on the drought of 25, but the drought of 26. The rains are still delayed for coming, and we have new breaking records of temperatures of the hottest November recorded, and we can all put this in a climatic change that we are at right now. And so the objective of the study is to assess the extent of tree mortality associated with the drought, and evaluate differences in drought tolerance among the pine species, a little bit of what Eitan has showed before. And the research area is up the north. We added the area of Ben Shemen, and the south, Be'er Sheva, Yar Yatir, and up to the western Negev. Altogether, an area of planted trees of 115 dunams of conifer trees, and I zoomed in only on conifer, mostly pines. Database, I use the stations of the Meteorological Survey from north to south, west to east, Sora, Kiryat Gat, Dorot, Psor, and Shani. This is their multi-yearly average, and this is the last year, and we can see that we are between 50%, a little bit more, a little bit less, in all of the stations as the average in all of Israel. My tools are remote sensing, satellite imagery. I use two satellites to assess the mortality. The first is the Sentinel, where I won't go into technicalities, but I calculated the percentage of loss. I looked at the NDVI, the minimum NDVI of 2025, and I reduced the 2017 to 2021, divided by the 2017-2021. And I get the percentage of loss, how much this year was not as good as previous years. And the second thing is I looked on the MODIS time series, which is a long-term monitoring satellite, started at 2000 and reached until today. And so we can look at previous droughts and see how this drought is compared to droughts that we had 10, 15 years ago. These are the results, and this is the percentage of loss. In a moment I'll zoom in, but I classified in each polygon, in each forest polygon, I classified the percentage of loss and into how much decrease we had. So between 0 decrease to 20% of decrease, this is not significant. 20 to 30, low significance, low decrease, sorry, a moderate decrease, high decrease, and extreme high decrease of more than 50% of the functionality of the forest, of how much photosynthesis actually occurred. And let's zoom in, for example, Moran and Kramim, and this area helped us a lot to understand what we are seeing, because after I've done the calculation in the office, in the lab, and then we went to the field to understand what is percentage of loss and how it seems in the forest. So is 30% loss tree mortality? It means that the trees are dead or not. And this area has helped us a lot to see that on this Kramim area, 40 to 50 and more percentage of loss. And on the other side, we have 30 percentage of loss. And here the trees are completely dead. And here they are not in a good state, but they are still alive. And we use this threshold, which we've seen later on in Meitar and in other areas, that to determine a threshold of mortality. And how do we assess in such a large area the mortality. So from now on, every time that I'm speaking about mortality, I'm speaking about areas which have experienced more than 40% loss of in their functionality, in their photosynthesis, in their NDVI. Another example, the Yatir forest. All of these reds and purple areas are areas where more than 40% loss. It means that the largest planted forest in Israel has experienced about 50% mortality in this huge forest. Looking into the north, in the Tzora area, we see this significant purple, more than 50% decrease, and this is the catastrophic fire of 2025, which is probably as well drought related. But in the northern part of the Ben Shemen, we see a mortality rate of about 20 to 30%, which have experienced more than 40% decrease in the NDVI, in the functioning of the forest. And if we look in all of the forests together, this is I cluster the forest into gush. It means grouping the couple of forests and seeing what is the rate of mortality in each forest, which has experienced more than 40% decrease. And we are looking at 50%, 70% in the Ayalon Eshkol, Eshkol, 50% Ben Shemen, 70% alive, Grar about 50%, Dudaim, Yatir, etc. And all together, putting the threshold of 40%, we are looking at an area of irreversible damage of about 53,000 dunams of dead trees, and 45% of the total area. And this is when I used the 30% borderline. I extended a little bit more because this is not a clear line. If I use a 35%, it jumps much, much higher, and probably the truth lies somewhere in between. And here we're looking at about 60% of mortality. Very, very high mortality. And as far as I know, it's the largest mortality documented in Israel of planted trees. I've seen some numbers about the mortality after the 2008 and 8 and 9 drought, and it's about 10%. And this is the numbers that we are looking at right now. I wanted to check which species last better than other species. And I thought that I would identify that the Brutia dies more than the Jerusalem pine, but I haven't found that. I've seen high mortality in all species. I classified them only to four types. It could be a little bit more detailed, but in general, I haven't seen a significantly high mortality in one or high ability to survive in one than the other, and at this large extent. And another glimpse of why I use the MODIS NDVI. This helped me to understand better the drought and the characteristics of the drought. And so just for you to see that this starts at 2000, and this is the NDVI, ends at 2025, and every peak is 1 year. The peak goes usually around March, when the high activity of the vegetation, the high photosynthesis, and the lows comes around between August and October. And we can see that the peak of the last year, this is 2025 in red, was low relatively to other years, but it's not the lowest. 2008 was lower. But yet, after each peak, we should see in the mid-start of November, we should see the positive slide, the positive slope. And the positive slope we don't see. And the positive slope, it's just in these days, and I'm still waiting to get the new MODI satellite imagery to see whether the forest wakes up. But as I see it, the mortality is what occurs here. It's the drop down here, where the rains of November are delayed, and the forest is thirsty and doesn't wake up. So we see it, I show here Yatir and Dudaim, but this kind of extra inch down is the mortality that the severe mortality that we see. And this is about it. Conclusion of the central and southern KKL forests. We see a mortality rate of between 45 to 60% of the area is irreversibly dead, unfortunately. Species sensitivity, I haven't found a clear better survival in one compared to the other. And we are still in ongoing effects. The drought, maybe we finished with the drought of 25, and I cannot say that if we are in the drought of 26, but we are in a delayed rains of 26, and when we go to the forest, we see that the forests are still collapsing and are still in this situation. And up ahead, or how I see to tackle this, because it's, of course, in these numbers, it requires rethinking of a lot of how to plant, how do you plant, and as Eitan said, on this slope, on that slope, on different types, I would suggest to approach machine learning models and kind of putting in a lot of variables, understanding the slope, the climate, plantation types, and things like that. And that is it. Thank you very much for listening. And special thanks. Okay, first of all, the study that we've seen was an ad hoc study that I got in communication with KKL just 2 months ago, and we started doing this as fast as possible to get a sense of what's going on in the field. The first round, I've used one index of remote sensing, and then we went out to the field to see whether it's correct or not, whether I see a 30% decrease. Is it true in the field that this is actually, does it mean that it's dead or not? After that, we saw that it's not quite accurate, and I came back to the lab, did a few more calculations, tried a new index, and I saw that it's more accurate. And I cannot say that it's 40% is mortality in every spot, but this is like, and it requires, and hopefully next week I'll go in the field again to see that how correct I am. Now I was asked to work on the pines. In general, in this kind of raw resolution of spectral resolution, it's not maybe phenologically wise. I'm not sure. I looked at pines. At the starting point, I looked at areas which are mostly planted by pines. When I went to the field, I've seen the eucalyptus are in better state, and the ela and the acacias are in better state than the pines. But my polygons are focused on the pines. It's the next stage, exactly. Yes, it's I 100% agree, and this is why when I showed that in the MODIS time series, I'm not sure whether the slope is 100%. I'm assuming that the start of the slope is the undersaw of the forest. And I will need to have a few more months to get more images to see whether we have a different waking up which is related to the forest. The calculation based on the Sentinel, the first time series, I used the minimum NDVI. It means I looked at what was the photosynthesis, what was the activity at the lowest time of the forest. And so it's for sure it's not the dry season. It is the dry season without the under. We had first of all, I didn't have time to go into that, and I don't have the right satellites to do this type of analysis. And it's worth looking at because I see that from the papers of 2008, it's much more general. It's not in such detail because I think that the imagery was not as the satellite imagery is not as available as today.